Hello everyone, and I hope you're doing well everywhere you are. I was validating my numerical simulation, and so I had to compare my results with a benchmark. When I'm talking about a benchmark, it can be your experimental data, or it can be validated results from literature. Okay? So I had to import the dimensionless velocity profile align different lines into Ansys CFD-Post to have a precise comparison, and so I decided to share this procedure. You can even plot any variable as a function of another variable. It just needs to obey the template provided by Ansys Corporation. And now here, I'm gonna be talking about it. This is the template file, and it can be a text file or in CSV format. The key elements are name, data, and lines. In the name section, you must define the name of your line, and you can choose any name arbitrarily. In the data section, you must define your data, and you must notify that the X, Y, and Z coordinates are essential and must be included in every file. Any other variables can be chosen arbitrarily, and it can be a dimensional or non-dimensional variable. Okay, this is the name of your variable, and this is the dimension. For example, you can bring pressure, temperature, or velocity in order to plot these variables as a function of X, Y, or Z components. And below this section, you must bring your numerical values of these variables. For example, X, Y, Z, or velocity profile are here, and your data must include 4 columns. Okay, and the lines section will define the connectivity between your data, and it doesn't need to be changed, and 0 and 1 are okay for your purpose. So let's have a look into a practical case that I prepared. Okay, I run CFD-Post in order to import my velocity profile. This is the Z line, the result of Z line from Montazeri and Montazeri 2018 work. So I open it, and I compare it with the template file. As I stated, this is the name section, Z line Montazeri and Montazeri 2018, data X, Y, and Z, and Z dimensionless velocity. Your data, this is the data I exported from their work. 1, 2, 3, and 4 columns, and this is the line section, 0 and 1. So I close it, as well as this file, and don't save. This is the Z line, and I want to plot the velocity profile along this line. This is from the result of Fluent, and now I'm gonna add the data from Montazeri and Montazeri results. So in the Z-line data series, I create a new one and I name it, for example, Z-line from the work of Montazeri and Montazeri 2018. And because I want to load the data from my file, I choose the file option, and now I load the CSV file. And this is the Z line. The x-axis must be dimensionless velocity and the y-axis must be the z coordinate. And I apply, and now I can have a precise comparison between these two quantities. Okay, or even you can import the x-line velocity similarly, and for example I name it x-line and again x-line, the x-axis is x and the y-axis is dimensionless velocity along this line. And now we can compare our result with the result of Montazeri and Montazeri 2018 work. Okay, or even you can export your variable profile using this option simply, and for example the location can be any location, x-line or z-line, and this is the variables, for example normalized velocity magnitude, and I can save in the CSV format, and I can save it and I can use this data to compare in a third party software, for example in Microsoft Excel, in order to have a precise comparison. This file must be here. This is our line and the normalized velocity magnitude. Thank you so much for watching this video, and if there is any question, comment, etc., you can leave a comment below this video or you can send me an email. Thank you so much.